Welcome my dear learners for this course on mechanical vibrations. In this module 2 we were discussing on forced vibration and measuring instruments. So far we have discussed the system response for forced vibration under harmonic excitation, and also we have discussed reciprocating and rotating unbalance, and in our previous lecture we have also discussed support motion, that is displacement ratio for absolute displacements and for relative motion also. Now continuing from the point where we have stopped in our previous lecture, moving ahead in today's lecture I am going to address vibration isolation and transmissibility. In many mechanical machines which we use like lathe etc. are all subjected for vibrations. Now we should not mount the machineries directly to the foundation. This is because of the reason the amount of vibration generated should not be transmitted directly to the foundation, which may lead to the sudden breakage or failure of the equipment. So therefore what we should do is that we should keep some isolators. Isolators are nothing but the devices which absorb the vibration generated to certain amount and transmit a fraction of remaining to the foundation. So by using isolators we can control the amount of force or motion transmitted from the vibrating object to the foundation. The vibration isolators are the devices which absorbs the amount of vibration transmitted from the vibrating object and allow only fraction of it to pass through them. Now the examples for vibration isolators are springs, dampers such as cork, rubber, etc. The two main things, there should not be any rigid connection between the machinery and the foundation. That is the first thing to be accounted, and second important thing is that even though the isolators fails, the connection between the machinery and foundation should not become direct, it should be through the isolators only. What I mean to say is that even though the isolator present between the vibrating object and the foundation fails, the connection between the vibrating object and the isolator should not disengage. They should be connected engaging only. This is because to safeguard the machinery. So whenever we want to mount an mechanical equipment on a foundation, always we should ensure that we will use isolators. The most popular isolators are rubber, cork and spring. Coming for spring, we have leaf spring, helical spring, etc. Whereas the rubber is very good isolator when it is used for shearing loads, to take up shearing loads. Whereas the cork is very good isolator when it is used to take up compressive loads. Whereas springs can be employed in both the working conditions because it is not affected by water, air, oil, etc. So therefore what I mean to say is that we can use rubber as a very good isolator when the shearing loads are transmitting from the vibrating object to the foundation. Whereas cork can be used as an isolator when compressive loads are transmitting from the vibrating object to the foundation. Whereas spring can be employed in all the working conditions. So what we have discussed so far is vibration isolators. Vibration isolators and transmissibility Hope people understood what is the meaning of vibration isolators. So the popular isolators are rubber, second one is cork, and third one is spring. So where it is suitable to apply these isolators? Shearing load, compression load, all working conditions. Including high frequency applications, high frequency ratio applications, we can use springs. So this is about vibration isolators. Now what about transmissibility? What is the meaning of transmissibility? We know that the force generated or force applied in order to vibrate the object can be externally applied or it can be internally generated because of unbalance. As we have already analyzed reciprocating and rotating unbalance, we have seen that the unbalanced setup in the system will cause excitation and it will cause forced vibration in the system, correct? Now if you carefully observe, between the support and the mass, the connection is through the spring and the damper, correct? In order to actuate this, we are applying some external force. Let us say we are applying some external force, that is what we call it as disturbance force. Let us take it as F. And now this vibrating object will transmit some amount of force to the foundation, correct? The connection between the vibrating object and the support is through what? Spring and dashpot, which are nothing but isolators. So the force transmitted from the vibrating body to the foundation is through what? Through spring and damper, because spring and damper will absorb some amount of motion or force and allow only fraction of remaining thing to pass through them. So therefore the connection or force which is transmitted to the base is nothing but spring force and damping force. The inertia force will not transmit to the base. Will you agree? Yes, that is what we can see from the diagram, correct? Now the force transmitted to the foundation, to the force applied or the external disturbance force is termed as transmissibility ratio. The ratio of force transmitted to the foundation to the disturbance force is termed as transmissibility ratio. Now let us analyze what is this transmissibility ratio. Now as I said, the force transmitted to the base is through spring and dashpot, correct? So therefore let us say the displacement is given by A sin omega t, correct? I am discussing about transmissibility. That is force transmissibility. The force transmitted is because of spring and dashpot. Spring and dashpot. Now if the magnitude of vibration or motion is given by x is equal to A sin omega t, where A is the amplitude of vibration, then what is the maximum spring force? Maximum spring force will become K into A. A is the amplitude, correct? Stiffness is defined as force per deflection. What is the maximum deflection? A. So therefore spring force is nothing but K into A. Whereas dashpot is Cx dot. What is the value of x dot? X dot will become A omega cos omega t. What is the maximum velocity? The maximum velocity will be A omega, because the maximum value of cos theta is 1, correct? That is what I mean to say. X dot is equal to what? A omega cos omega t. Now what is the value of maximum displacement x? That is A. Now what is the value of maximum velocity? Maximum velocity will become A omega. Now the force transmitted is the resultant force due to spring force and dashpot. So therefore force transmitted from the vibrating body is nothing but resultant force, that is square root of spring force is Ka square plus dashpot force. Dashpot force is damping coefficient into velocity. What is the maximum velocity? A omega whole square. So this is the force transmitted to the foundation, correct? And now what about the force applied? Let force, that is disturbance force, let us call this as Ft. We have already called it as Ft. Now the disturbance force, let disturbance force for vibration, let the disturbance force for vibration F is given by F naught sin omega t. Let the disturbance force F is given by F naught sin omega t. So if the disturbance force is given by F is equal to F naught sin omega t, then you recall as usual, amplitude ratio. If I recall amplitude ratio, for all the derivations we will recollect amplitude ratio and substitute for f0. So recall amplitude ratio or magnification factor, which we have discussed in our lecture 1 of this module, that is forced vibration analysis using harmonic excitation. The amplitude ratio is given by what? A is equal to f0 by k, which is nothing but f0 by k is what? F0 by k is nothing but static deflection divided by square root of 1 minus omega by omega n whole square plus 2 zeta omega by omega n whole square under the root. Right, let me write zeta properly. 2 zeta omega by omega n whole square. Now I want to take the ratio of force transmitted, this is the force transmitted, and f0. So what is the maximum force? Maximum disturbance force is nothing but f0, because the maximum value of sin omega t is 1. So f max is nothing but f0. Now if I write the transmissibility or transmissibility ratio, that is transmissibility ratio is defined as T dot R. Transmissibility ratio is nothing but force transmitted to force excitation force or disturbance force. Now if I substitute and solve, what I will get? The transmissibility ratio as Ft by f0 is equal to, what is the value of f0? F0 is equal to, f0 will become what? A into k into root of A into k into root of 1 minus omega by omega n whole square plus 2 zeta omega by omega n whole square. Correct? Now what is the force transmitted? Force transmitted is because of spring force and dashpot force, which is given by A into root of k square plus c omega whole square. Right, now I can simplify further and solve. Force transmitted is equal to Ft by f0, which is nothing but k into root of 1 plus c omega by k whole square divided by k into root of 1 minus omega by omega n whole square plus 2 zeta omega by omega n whole square. Right, now what is the value of c omega by k? C omega by k is nothing but 2 zeta omega by omega n. If you are following my lectures from the beginning, you know how we have simplified c omega by k as 2 zeta omega by omega n. For new joinees, let me simplify it once again. That is c omega by k can be written as c by cc into cc by 2m into 2m by k into omega. Correct? So c by cc is zeta, cc by 2m is omega n, 2m by k is 1 by omega n square into omega. So this can be written as what? Zeta into omega n into 2 by omega n square into omega. This square and this will get cancelled. Now I can write it as 2 zeta omega by omega n is the value of c omega by k. So hence, what is the value of transmissibility ratio? Hence transmissibility ratio, which is nothing but force transmitted to the disturbance force, which is nothing but the displacement ratio of absolute displacement, because this expression is same as A by B, which we have derived in our previous lecture. So hence the expression for transmissibility ratio is square root of 1 plus 2 zeta omega by omega n whole square through divided by square root of 1 minus omega by omega n whole square plus 2 zeta omega by omega n whole square. So this is the expression for transmissibility ratio, which is defined as the ratio of force transmitted from the vibrating object to the foundation to the disturbance force. Now what is the phase difference between these two? What is the phase difference between the force transmitted and the force applied, or the disturbance force is the question. Now recollect the equilibrium equation or equation of motion for forced vibration under harmonic excitation, which we have discussed in our lecture 1 of this module. If I recollect that and draw the curve, so draw the graphical representation of summation of f is equal to 0, what we have is like this, correct? I think you remember this diagram. This is a reference I took, correct? So this is a reference we took, and the force applied will come like this. So this is force applied, let us take it as magnitude as F0, and we have the spring force like this. Spring force is Ka, perpendicular to which we had damping force C omega A, and then we had at an angle of 180 degree to spring force we had inertia force. Inertia force is given by what? M omega square A, correct? So this is what we had. Now if I represent the angles, let me use different chalk. So if I use to represent the angles, so this angle is already known to me, correct? What is this angle? This angle is omega t, and this angle is already known to me, that is phi, correct? Now what is the transmissibility force? Transmissibility force is the resultant of spring and dashpot only. So for spring and dashpot you connect spring and dashpot, take the resultant. So this is the resultant of spring and dashpot. This is the resultant of spring and dashpot, correct? Now we have the resultant like this here. Now take this angle as alpha. Take this angle as alpha, which we have discussed in our previous lecture when we had discussion on A by B, displacement ratio. So this angle is alpha. Now what is the angle between Ft and F0? What is the phase difference between disturbance force and the transmitted force? Disturbance force and transmitted force is this, correct? So what is this angle? What is this angle is the question mark now. What is the distance, or what is the angle between F0 and Ft? So analyze the angle between F0 and Ft. So F0 and Ft, the angle between F0 and Ft is nothing but this angle is already known for us, that is phi. So this angle is how much? Phi minus alpha, correct? The answer is phi minus alpha. The answer is phi minus alpha. Phi minus alpha is the phase difference between force transmitted and the disturbance force. So hence the phase difference between what? Transmitted force and disturbance force F0 is nothing but phi minus alpha, is phi minus alpha. Now what is the value of phi? We know that tan phi and tan alpha, both the equations are known to you people. Tan phi is given by 2 zeta omega by omega n divided by 1 minus omega by omega n whole square, whereas tan alpha is given by 2 zeta omega by omega n. Now find the value of phi and alpha. Find the value of phi and alpha. Take the difference, that will give you the phase difference between force transmitted and the disturbance force. So this is the concept of vibration isolation and transmissibility. That's all from this lecture. Thank you all.